Back in lesson 3A, we were doing a direct variation, and that was kx. And k was the constant of variation. We're still going to have a constant of variation, but it's going to be done a little differently. For example, I could have had a problem that was, let's say, y equals 25x. If I was doing that as an example, when you put in 0, 0 has to come out. Otherwise, it's not going to be a direct variation. But if I would put in 2 essentially 25 times 2 would be 50. If I would put 6 in, 25 times 6 would be 150. And the idea would be is that essentially you could think I'm being paid 25 bucks an hour. So if I work 10 hours, I would expect to have maybe $250. That was a direct variation. What we are going to be doing is called an inverse variation, also known as inversely proportional. Okay? Inversely proportional. And the difference is, instead of y equaling k times x, it's going to be y equals k divided by x. Another way to write this equation is if you multiply both sides by x, you could actually write this as xy equal to k. And for some people, that's actually an easier way to do this. So this and this both set up an inverse variation. Let me give you an example of what I'm talking about. And I think in this case, it'll be easier to see this formula than it is the formula over here. For instance, if I took x and y and multiply them together, I would get 48. You're going to find out that this is going to stay the same if I go 3 times 16 equals 48, 8 times 6 equals 48, 12 times 4 equals 48. So essentially what's going on is, as x is increasing, y is decreasing. And in fact, that constant would go into this spot and it would end up being 48. Now, if you would like an example of this, which is a really simple example, all of us have had experience driving, so you could think of this as, okay, basically it could be the number of hours and the miles per hour. And if you're trying to travel a 48-mile trip, okay, if you drive for 1 hour, you're probably driving 48 miles per hour on average. But if you're driving for 3 hours because construction is terrible and there's a blizzard, you may be only driving 16 miles per hour. A relationship where rate and time is inversely proportional to the distance that you want to travel. So essentially, here's what ends up happening, and now this brings in some of the other concepts we talked about. As you increase your x's, y decreases and approaches 0. It's going to keep getting smaller and smaller. So again, another way to think of it is if you drive faster, it takes less time to get to where you need to go. Now, I'm not going to say that you're going to get to 0, but you're going to keep approaching it. And as x actually approaches to 0, y is going to approach infinity. So essentially, as one goes up, the other one's going closer and closer to 0. This is why it's also known as the reciprocal function. And that was one of the parent functions. In fact, that's the reciprocal function right there. One more time. Direct variation is y equals kx. Inverse variation is y equals k divided by x, or you multiply xy and you get k. Are the following tables direct variations, inverse variations, or neither? If it was direct, you would be asking yourself, if I go 0.2 and I multiply this by some constant, and you can think of this as x, you can think of it as k, and it gets equal to 500, and I can do that all the way down the line and get the same number, then it's direct. And here, I'll use this as an example. I happen to have 1 times k, and that is equals 140, so k would have to be 140. But you can see here, 2.5 times 140 is not 64. So this is not direct. And that's really how you figure out direct. Am I multiplying by the same number to x to get to my y value? That's not the case. In fact, what I'm seeing is as my x's are increasing, my y's are decreasing. So there's a better chance that this might actually be inverse relationship. So I'm going to erase this now. Bye-bye. And what I'm going to try now is I'm going to ask myself is what happens if I would multiply x and y together? Do I get the same constant? The first time I multiply 0.2 by 500, I came up with 100. Now, if this stays the same way all the way through, we're in good shape. But the problem is the moment I get 0.75 times 160 equal 120, these are no longer matching. And the idea of this being an inverse variation isn't going to work either. So in this case, this truly was neither. It was not direct. It was not inverse. It was neither. Let's try the next one. Some of the cues to know if I should be looking at if it's direct or inverse is what's happening to my x's and my y's. You can have constants be negative numbers. So technically, a number could be going up and the other number going down. I'm looking at the absolute value. I'm looking at the magnitude of the numbers. Now, luckily for all of this, all these numbers are positive. And I'm noticing that as my x's are increasing, my y's are also increasing. This is more likely to be a direct variation than it is to be an inverse variation. Now, all I have to do is figure out, what number can I multiply to 0.2 to get 16? What number can I multiply to 0.75 to get to 60? What do I multiply 1 by to get to 80? Well, that one's pretty easy. K is 80. If you have 1 really does make your life easier when doing the problems. So now the question is, will 80 work for all the other ones? And so let's take a look back. 0.2 times 80 equals 16? Yes, it does. Does 0.75 times 80 equal 60? The answer is yes, it does. How about 2.5 times 80 equals 200? And the answer is yes. The constant is 80 all the way through the process, and that would be my constant, and I could say that this is a direct variation. In fact, I could even write the equation. I could write the equation as y equals, I'm always taking my value of x and multiplying it by 80, and that's how I get my y. Yes, in this problem, I gave you 1 and made it easy to find your 80, but if I don't give you 1, you can still actually go ahead and just figure out k by taking 16 and dividing it by 0.2. You could have found k by taking 60 divided by 0.75. You could have taken k and taken 200 and divided by 2.5 because 2.5k equals 200. So solve for it. The fact is every number in x got multiplied by 80. Let's try the last example. The last example says as follows. I got 0.2, I got 0.75, so I'm still using the same x's, and they're still increasing. But I'm noticing that as I increase my x's, my y's are decreasing. This is most likely going to be inverse or not inverse, but it's definitely not going to be direct. So let's just take that out. Let's just ask ourselves, is this inverse? In this case, does x times y equal k? Well, let's be honest, 1 times 60 is easy for us to do without a calculator. Now it's up to you to check to see, does 0.2 times 300 equal 60? Does 0.75 times 80 equal 60? Does 2.4 times 24 equal 60? And the answer to those questions is yes, they are. And if it maintains that constant, then this is no longer a question mark. The answer is, yeah, it's an inverse variation. You can simply write y is always going to equal 60 divided by your x. Or you can write xy equals 60. This is a great, great example of miles per hour. I mean, 60 miles per hour is, traditionally what a lot of people think when you're driving on a highway. Okay? And so if you were going to go on, let's say, if you were going to travel 300 miles per hour, it would only take you 0.2 of an hour to get there. Of course, you might be breaking a few laws. If you're going 80 miles per hour, you're still breaking some laws, but you'll be there in 3/4 of an hour. If you're driving 24 miles per hour, you're probably doing backcountry and construction, and it's going to take you 2.5 hours to travel 60 miles. That's a very good example of how an inverse variation works. So what other kind of examples can I have? I don't have too many left. I have a couple right here. I have a relationship already where x is 15 and y is 27. So maybe it's a point 15, 27. The fact that it says it is going to be an inverse variation basically says that I can take my x, I can take my y, multiply them together, and I will get my constant. So if I take 15 and I multiply by 27, it says I'm going to come up with 405. So now, if I'm being asked what is the equation, what is the function, I could write, y equals 405 divided by x. And honestly, that would probably be all I would want to do. I mean, I could rewrite it as, xy equals 405, but this would be helpful, y equals 405 over x, because over here, I want you to find y when x is 8. So for this example, when x is 8, and this is just a fancy way of saying I'm trying to find y for this particular case, I'm just going to take 405 divided by 8, which works out to be 50.625. So there would be the function. There would be our answer for when y equals x equals 8. Nothing's going to change except for the numbers. X equals 3, y is 725. So again, for an inverse variation, it's really easy. Just take your x's and y's, multiply them together, and you'll get your k. So 3 times 725 works out to be 2175. Got here y equals 2175 all over x. And so when I want to figure out what y is going to be, all I have to do is just take 2175 and divide it by 8, specifically when x is equal to 8. And that worked out to be 271.875. Here we go. This is it. My last example, and then we're done. So in this particular example, I have an organization that's taken on our school forest out there. It's estimated that the litter is the same amount in past cleanups, so he's trying to figure out how many people can we get to volunteer. All right, and in the past, he's seen that he's had 4 students, and it took roughly 63 minutes to get that cleaned up. 7 students took 36 minutes, 9 took 28, and 12 took 21. You know what I'm saying here? As the number of students are increasing, the time it takes to do the job, it decreases. This sure sounds like an inverse proportional situation. So I guess what I'm trying to say is, if we think of the number of students, let's just say S is the number of students, and M represents the cleanup, then I guess if I took S and I multiplied it by M, I would hopefully think I would be getting some form of a constant, and it'd be like student minutes required. And let's take a look. When I went 4 times 63, I got 252. And when I went 7 times 36, I got 252. And when I got 9 times 28, I got 252. What a coincidence how these all worked out so nicely. And 12 times 21, that's right, 252. So it seems it takes 252 student minutes to clean up a school forest. So if I was asking you to make an equation or prediction of, hey, I'll tell you the number of students, I think it's pretty safe to say that the number of minutes is going to be based on taking 252 and dividing it by the number of students. So there's the model. Ta-da! Now, if you want to actually apply it, that would be the equation, so that would be this. If you want to actually apply it for 14 students, I would just take 252 and divide it by 14, and it seems that you could have the whole job done in 18 minutes.